Determining the required oxidant dosage needed to produce the desired free available chlorine residual for waters with unknown composition is typically achieved using an oxidant demand test. When used appropriately, the data generated from this procedure will give MIOX and the customer information regarding the mixed oxidant solution or hypochlorite dose level required to produce the desired free chlorine residual. It also serves as a way to allow MIOX to provide accurate information regarding equipment sizing for the desired application. To follow this procedure, first gather the required laboratory equipment. Appropriate personal protective equipment and dress for working in a laboratory environment. Source of the oxidant to be used in the test, including MIOX MSR disinfection pen, MIOX commercial system, or commercial hypochlorite system. If mixed oxidant solution or hypochlorite from a MIOX system is to be used in this test, the exact chlorine concentration of the oxidant needs to be measured prior to beginning the test. If a commercial hypochlorite solution is to be used in this test, the solution should be diluted to a chlorine concentration of around 1% and the exact chlorine concentration measured prior to this test. A chlorine spectrometer colorimeter test kit, for example, the Pocket Colorimeter 2 from Hach. A micropipetter with a 10 to 100 microliter range and clean disposable micropipette tips. A supply of oxidant demand-free water. If oxidant demand-free water is not available, deionized, ultrapure, or distilled water can also be used. Beakers or other similar laboratory glassware for dosing small samples of the raw water. These beakers should have a capacity of at least 250 milliliters. Volumetric flasks as needed to dilute samples. Approximately 1 gallon of water should be collected to ensure an adequate supply for an oxidant demand test. Water should be collected in a sealable plastic container. MIOX can provide a sample kit if needed. Just contact your MIOX representative to arrange for a kit to be delivered to your location. If there's more than an hour before the sample is to be analyzed or shipped, the water sample should be stored in a laboratory refrigerator. All results obtained from this test, as well as sample and oxidant information, are to be recorded in the data table provided by the written procedure for MIOX. The first step in this test is to measure the chlorine content of the hypochlorite or mixed oxidant solution. This is accomplished by diluting a small sample of the initial solution in a volumetric flask. The diluted sample can then be analyzed, providing the chlorine content of the original solution. The exact sample sizes and dilution volumes required for this test will depend on the source of your chlorine solution. Examples for how to determine these volumes can be found in the accompanying graphics. For example, when measuring the chlorine content of a mixed oxidant solution, here's the procedure you should use. First, transfer 100 microliters of the mixed oxidant solution into a 250 milliliter volumetric flask. Fill the volumetric flask to the fill line with oxidant demand-free, ultrapure, deionized, or distilled water. Mix the sample thoroughly. Measure the chlorine concentration of the dilute sample and multiply by 2,500 to determine the chlorine content of the mixed oxidant solution. Fill 6 beakers or flasks with 200 milliliters of raw water. Beakers or flasks should have a capacity of at least 250 milliliters. Add mixed oxidant solution or hypochlorite to each flask to achieve a target chlorine dose. Calculate the amount of mixed oxidant solution or hypochlorite to be added to the sample using this equation. In this equation, V oxidant is the volume of oxidant to add to the 200 milliliter raw water sample. C sample is the target chlorine dose of the sample in milligrams per liter. C oxidant is the chlorine concentration of the mixed oxidant solution or hypochlorite solution in milligrams per liter. For waters with an expected low oxidant demand, a good series of initial chlorine doses is 2, 4, 6, 8, and 10 milligrams per liter. If the water is known to contain ammonia, hydrogen sulfide, iron, or manganese, higher target chlorine doses may be required to achieve a free chlorine residual. Next, allow the sample to react for 20 minutes, swirling the sample occasionally to ensure that the water is properly mixed. After 20 minutes, measure and record the chlorine residual of the sample. Depending on the detection limit of the chlorine measurement kit, the dosed water may need to be diluted using oxidant demand-free, ultra-pure, deionized, or distilled water. If required or desired, additional target chlorine doses can be used to treat additional samples. Make sure to thoroughly clean the beakers or flasks used in the first sample set with oxidant demand-free, ultra-pure, deionized, or distilled water before reusing. Calculate the oxidant demand of the water by subtracting the residual chlorine concentration from the target chlorine dose. Ideally, this calculation should be made on several samples and then averaged to provide the most accurate oxidant demand measurement. Here are the instructions for shipping water samples for testing. Water samples shipped to MIOX must be coordinated with MIOX laboratory staff prior to shipment to ensure that the samples are treated properly upon arrival to MIOX. Contact your MIOX sales representative in advance of submitting samples to the MIOX laboratory. Collected samples are repacked in a cooler along with sufficient blue ice packs to keep the sample chilled for the duration of the shipping. Samples are to be shipped overnight to MIOX. Tracking number information needs to be emailed to your MIOX sales representative once it has been obtained from the shipper. Upon arrival at MIOX, samples will be immediately unpacked and stored in a laboratory refrigerator until the oxidant demand test is performed. It is critical that sample acquisition and shipping instructions are followed as stated to preserve the integrity of the sample and accuracy of the subsequent oxidant demand test.